So here, and so this is a machine and they use to print for printing. So here is one person standing in front of this wall that have been fabricated layer by layer. You can see this is the wall how they print. They have 3 nozzles. One nozzle just build this wall. Another nozzle build this wall. In the middle nozzle, and they will just build this reinforcement. This is a pattern. So after they build out all these materials solidified, and we can have this one. This is very awesome. So this is for the concrete. People can use different material. People can use the metallic material. For example, titanium alloy powders to build the titanium. To build the titanium is the products, 3D printed products. So here is a contour crafting how his company evolves from 1986 until 2015. So you guys can take a look later. So that is the past. Present. So why construction needs a change? So construction. So why construction needs a change? I don't know whether you can see this. This is the text or not. So the construction is the largest sector of almost all economies. So this construction is is a developing country. Labor efficiency is alarmingly low. Labor efficiency. It is skilled workforce is vanishing, and worker quality is low, and control of the construction site is insufficient and difficult. This is accident rate at construction site is high, and waste and disease claims are high, and this low income housing and emergency shelter are critical. So all other all other products are fabricated automatically. Construction is still largely a manual task. So currently, people want to use something and to automate the construction of big building. So current progress of construction 3D printing community is on building construction. So for residential, for the houses and the people live, and for commercial, and for residential, and the shortage of 800 million houses worldwide. So this is worldwide, not for US. The global markets are grossly underserved. Nearly 2 billion people are homeless or live in slums. Annually, 37 million people lose housing due to war and other natural disasters. This for this residential. The commercial and shortage of commercial and industrial buildings, especially in developing countries. So barriers against the implementation. The barriers. So there are several barriers. First one is a conservative industry. A low profit margin, regulatory barrier, the paradigm change requirement with respect to inspection, and labor unions, and most importantly, the marginal impact of 3D printing, so limited primarily to the building shell. So this is the barriers. So future we want people want to do these things. Okay, so application in automated wind turbine tower construction. So you can see this one, right? So this is a tower, wind turbine tower. So this is very, very tall. If it is very tall, building it and will be very, very challenging. Now, and this is some so this professor came up with some idea that just suppose the assumption is that and he could have one this is automated, this is automated, this is a vehicle automated device. This guy can just build this is a turbine tower layer by layer, and at the same time, so this guy is being elevated by the tower this guy is doing, right? they build layer by layer, layer by layer by layer. So definitely, this another assumption is that the materials can be constantly supplied to these devices. So this is idea. How to implement it? That's another story. So here is okay. Oh, it does not work. I'm sorry, guys. So this is a Python this construction. So this is for this one compute is this is a Berkeley School of Engineering. This is University of South Carolina. So have you guys ever been to the USC, University of South Carolina? It's very, very awesome university. Very, very beautiful. Right? So I went there in 2017 to attend the MSEC conference. So we went there. They built this one. I can see this is they built. This is a pattern. This is a construction. So here, is our universe. So space mining. Space mining. This is the company. So this is company. There are several companies. This is Astrobotic. This is the technology. You can see Astra. There is a robotic here, right? Whenever we see this word as something automated. And secondly, under the car, so Moon Express, the Shamayan, this innovation partnership, planetary resources, and deep space industry. So this is target the body and objective. And there's a lot of companies they want to do some business in this universe. So here, so I like this picture very, very much. So as you can see, this is from NASA. And suppose people can move to the moon, right? So first, we should build. People should build houses for these people, for themselves. We agree. So how to build it? We want to bring this is very, very expensive. These materials from Earth. So this is good. This idea is good, but it's not feasible. Why? Because the payload, right? So if we want to bring a lot of materials from the Earth and to the moon, and with a lot of money, with a lot of fuels, and with a lot of things. So what is the best idea to build houses on the moon? We just use the dust on the moon. And we just bring the components for this is automatic, this is robotics. This robotic compute the work for us for humans. So here, suppose we have this bulldozer and we have this automated machine. This guy compute this compute the work for people. So here, so if we want to build now, you can see it's very, very amazing to build. This is buildings using this 3D printing. And what is most important is that the machine, how to control it. So here is the industrial robot, and here and how they build this machine. First, you need to have this machine, and then you have several nozzles here, and then you can build what you want. So here, this is the wall, and they build. And so this is another complex things they build. So as you can see, this is one layer, this is another layer. So here is the shape. So here is a shelter, and just the 3D printed. Here's the shelter. Here's the shelter, and we suppose this is on the moon surface, this shelter, and all this equipment can be put in the shelter. You can see, so this is the animation of this is the robot of building this wall. So this is I like this picture very well. You can see, feed the new material and then build another layer. So this material can be used, can be obtained from this is the moon surface. Have you guys ever been to the moon?
And I'm assuming that should be like solar power, or how would that work?
Yeah, so this is just ideal, right? So this is the idealization phase. And how to build it, the solar power is one of the best options. Why? Because we don't need to bring the batteries on right? So maybe 50 years later, and traveling to the moon will be very easy as we just travel from US to China. How does that sound? 50 years later, how old are you?
50 years from now?
Yeah, 72? Huh?
40 years from now, right?
50, are you
50, oh, 70.
Okay. Good, you guys still have a chance, but I don't have a chance.
Who knows?
Yeah, come on now, Michael's gonna develop a way to keep you around.
Even
No, sorry,
after
sorry.
50 years, you will have very healthy outdoor COVID because I'm very old, right? I don't want to take this risk. I'm kidding, okay? Living on Earth is very safe. I need to admit that. So here is a NASA from this NASA. So new large scale AM is processes. This they can 3D printing is very ideal candidate for printing very complex shapes. So here is the print. So here, selective, this is the printing. A new large-scale powder-based 3D printing technology. Large-scale powder-based powder. This is powder. You have a 3D printing technology. You have selective. So you just melt. You just selectively melt some parts, and then this molten material will be solidified, and then you get what you want. For other parts, they're still powder. So when you take this guy out, and powders are still powder, but you can take something, the concrete out. So this is NASA awarded as the grand prize. So other research directions, process innovation and improvement, materials is very important, impact on BIM and BIM integration. And so this is Internet of Technologies and synergies. And so here is the professor's company from USC Control Crowding. And so here is the end of this presentation. Okay, are you guys amazed? Very exciting, right? Okay, just to know some ideas. So this one will not be tested on the final exam. So, but I just wanted to broaden your horizon, to know something fun. And then we talk about another one. So this is also from the workshop I attended. This is US National Science Foundation. National Science Foundation is hosted. Let me show you. So this talk is given by Dr. Zofia Lubowski, I'm sorry, and this is Dr. Planter. So this is for TAM, the Texas Agriculture and Mechanical University. Here, Texas A&M. So this is the performative 3D printed building skin. So building skin towards adaptive the building environment. So this is from College of Architecture. You can see they are not from the mechanical engineering department anymore. They're from architecture. It's kind of art. The art is involved. So they just got this is the NSF Eager grants. Why they got Eager grants? Because this idea is very innovative. And so here, look at this art, right? So I'm a mechanical engineering guy. So I don't know too much about this. So you can see this is the leaf. So here is the leaf, right? So this is water going from the soil to the air, H2O. So here is how it goes. So there is some seeds there. This is very you guys are smaller than me, you can understand this, right? So this is so you can say this is air, this is building. The general strategy. And so you can see these butterflies. And they have different skins. Yeah, they want to see which one is better in terms of make the building more comfortable. So this is introduction. They build this one. They build this. You can see. They build. So this makes the skin of the building. The skin of the building is how to make the building more so people friendly. Okay. So you can see they build. Very good. We got different structures here. You can see this is the structure. This is what they built. This is a spherical dome. So this stuff from Dr. Calendar introduction. So here is the build. Okay, the build. And this one is very, very close to the very similar. They bought this idea from this is the from this insects from the nature. You can see different patterns for the building. So this is the Center for Design Research. So this is meter. Okay, so this is the wing of insect. So here is so this is CDR lab, and you can take a look if you are interested. So here this is what they built. This 3D printed. This one. This is a Trans Studio. So this is a prism, and they built, design, developed. Okay, the first skin, and second skin, and the third skin. So to build the building, okay, the user requirement, you have user requirement and functional space, and because different buildings, they might have different things here. And so you need to take care of the humidity and solar radiation, outside is air temperature, wind, sound. This is dynamic, static, if some earthquake comes, or this wind is very, very strong, and how this is the building will respond, and you need to take care of all these things. All these things, they are related to mechanical engineering, but how to build this building, the scheme of this building, and does it kind of art is involved. So you can see this mediator between inside and outside reaction to environmental changes and responses to the occupant needs. So when you build the building, and you have got to think all these three aspects. So could there a third skin be adaptive, similar to our first skin? So not really. The difference between nature and man-made constructions. So nature and man-made. So here is. Have you guys ever heard of mimicry? Mimicry.
Yeah, the nature.
Yeah, mimicry means that we borrow some idea from the nature and to accomplish something, right? So this is mimicry. So this is nature and man-made construction. So nature material is expensive, but the complexity is free. So this is from nature. But here complexity is expensive, while material is not man-made. What is man-made? So here, less material, more complex forms. So more material, less complex forms, man-made. You can see these is built by from the nature. So the better inspect approaches. So this is mimicry is one of these better inspect approaches. It's a smaller material and have new way to design adaptive to the building scheme and additive manufacturing technology. So you have this one to build the building. traditional design methods and traditional design method. The modeling is very, very important. The benefit of additive manufacturing in adaptive design. You can see, so here shows the picture. Local customization of geometry to change the properties of material. You can easily to accomplish this one. Reducing the number of susceptible mechanical parts such as hinges, and you can reduce the number of these kind of mechanical parts. All in one multifunctional component. So you need to build, you just 3D printed one component. Everything is through one process. That is very, very awesome. So here, so this is a 3D printing in adaptive design. We have two approaches. One is a geometrically informed, another one is a material-based approach. So first one is a performative properties are linked to the geometry of the mechanisms. So performative properties, okay, are linked to the geometry of mechanism. So here are the displacement and strategies. So here, material-based approach are synergetic relation between the material thresholds and performance. This is deformation, this is a displacement, and here is a deformation. It deforms material because the material based. The performative 3D printing strategy, passive strategy, and active strategy. And here, also passive strategy. So this is what they printed. So for these kind of components, I would say it is almost impossible to machine and using these traditional machining processes. Do you guys agree? And even though you use laser and use EDM, and maybe you use electrical chemical machining methods and build these kind of the components, I would say it's very, very impossible. However, for these kind of complex shapes, and people can use a 3D printing technology easily to get this done, just layer by layer, right? So see, these kind of things is impossible. So here, this is a mimicry. This is from the skin of this is some these insects. This is also very, very complex. You can see this building, and they have based on mimicry, right? So they know what kind of the patterns of the skin, and will have better. This is the properties better. This is can satisfy people's needs, and they want to build that kind of. This is the skin, and so they use 3D printer and 3D printing technology and to print these kind of complex shapes. So it's very, very good. Here you can see these kind of things. I cannot imagine how many hours and how many is the CNC machines we need and to build these kind of things. Right? So it's impossible. So this is after future research, a more severe angle of ventilation, the holes could not allow any direct standard penetration. So they are very, very awesome. So air is directed through the module and to be cooled a few degrees and then funneled upward along the bubbling, while sand is stopped by the angle of the opening and shed downwards via gravity. So this is how to improve the performance of this building. And they came up with a lot of beautiful ideas. So here, this is the skin of the house, and so this is wind and standard circulation, and you can see, and this is very, very beautiful, guys. Okay, this is, remember, this is conceptual, and you don't need to memorize anything, but just want to for you guys the horizon. You can see different patterns, and they will have different. This is the performance. This is very, very awesome. So there's a breathable wall. The wall system aims to satisfy the following criteria. First one, and get fresh air into the building and exhaust this air out, and block sand from penetrating into the building. So this one will be very, very useful in China, in northern part of China, because there's a lot of thunderstorms there. Cool down the air as it travels through the shaded zone and prevent light from direct entering the space. So here is the building they built, and so very, very beautiful. Wow, this is very, very beautiful, right? Look great. We cannot do this kind of, this is the surface of the wall successfully using the dimensional methods. That is called the passive. This is the active strategy they have. So with the joints, rigid like link is mechanisms. Another one is without joints, fractures the mechanisms. So here, the distinct joints. So here is embedded living the joints using two different materials, using single materials here. But here is without joints. So this is the local zones of flexibility to adjust the stiffness. So this is very awesome. The still continue active strategy. So these are distinct joints here. These are two. I use this guy to join these two guys together. Oh, it's very, very complicated, right? Very, very complicated. These are surveys, they use some mechanism to put them together. So here, this is mechanisms. So here is a mechanisms built, mechanical mechanisms. So here, this is this kind of like gears. That's very awesome. Here is air coming through this hole, orifice. This is a surface, is a wall, So here is a building, here is the wall they built, and it's very, 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 very good. So these are those different materials. So this is wall, it's a full building wall, right? So this is a wall they built. See? So this is the mimicry. It's want to just mimic the skin of some animal. That's amazing. You can see this is built this one. Here, this is a surface. Adaptive design, salt and fabrication. Formative 3D printing strategies. But another then we talk about local zones of flexibility to adjust the stiffness. So here, this one, this is the choice here. But this one, this is flexibility can be adjusted. See? So this one can be built, can be 3D printed. This one can be 3D printed also. So then talk about project management process. So here are the two, they are the group, they have weekly meeting, we'll just skip this one. Weekly meeting, also this weekly meeting. Here, so this is meeting. This is the minutes. We will not talk about it. You can see they build this one and thorough documentation of each meeting and lab sessions. So here is the surveys they built. This is a shared website. Okay, if you are interested, and you can just come here. You can see this one. Can you build this one? Oh, that's 3D printed very, very easy. These are surveys for the wall. It's very, very good. And I would suggest that if you are interested, you can come here to look at this. This is videos. This is very, very awesome, and you will learn a lot. There's some debriefing, and then report to the National Science Foundation. Here are some ideas. Okay, so these are two PAs and daughter. This is Rebecca Kowalski and daughter Clenter, and from the Texas A&M. Any questions from you guys? I just wanted to broaden the horizon, your horizon about this is advanced manufacturing technology, 3D printing to this